this video, we'll talk a little bit more about raster symbology and raster classification and reclassification. So what we're looking at here is the Euclidean distance raster that we created in class. And I've changed the symbology to be a kind of nice one. It's a stretched symbology using this color ramp from yellow to purple. And I don't know if we've done this, but if you click on Format Color Scheme, there's this little toggle that switches the ends of your color ramp. The default comes like this. So you see, well, I'll show you what you see when you do that. You get black spots where the explosions were, which is also cool and creepy in its own way. But if I go to Format Color Scheme and switch that, you get the kind of nice effect where the areas that were close to a nuclear explosion are highlighted. Now, this is just visualization. This is a stretched symbology. And I wanted to really get a handle on the percent clip histogram so that you understand what's going on with it. When you click on that histogram, you get a histogram of values. These are the distance values in the raster pixels. And you have two endpoints. This is where the yellow is set, and this is where the dark purple to black is set. By sliding these towards the center of the histogram, you can make more of the extreme values fall into the extreme color category. So for example, if I pull this slider down, a whole lot of the areas that had been shades of sort of purple to black now go to that darkest black color. And here, if I take the yellow end and I slide it up a bit, a lot more of the low values get smushed into the yellow area. In this particular example, I don't like this modification, but I want you to know that it's a modification that is available to you. Okay. I think we talked briefly in class about how you could clip this raster so that maybe we eliminate the oceans or something. We can use raster clip to do that. But right now, this goes from 0 to 9.5 times 10 to the 6th. Let's see what happens if we just raster clip like Africa. So if I just want to raster clip Africa, I need to select that polygon. Okay. And with it selected, I go get the raster clip tool. The input raster is this Euclidean distance. The output extent, I'm just going to let that take the default because we're just going to have a clipping of Africa. Oh no, what do I do? Sorry. The output extent is the continents with Africa selected, and then I need to click the box that says use input features for clipping geometry. Excuse me, that's right. And so this will be distance to explosion Africa. And that all seems fine. We run it. And I'll deselect Africa, clear selected features. And the thing I want you to notice is that the values that were available for Africa are now only half as much. It only goes to 4.6 times 10 to the 6th. What that means for symbology purposes is if I tried to use exactly the same color ramp, that sort of pretty one, let me find it. And I switch the endpoints. Okay. You will find that the new symbology doesn't really match the old symbology because the ramp of colors, the space from yellow to black, is divided up across half the range of values. So it's just something to be aware of. I mean, you could, if you needed it to be the same, you could probably go in here and, I don't know if you can pull this out now. But the thing to be aware of is you didn't do anything wrong. If the color ramp on a clip comes out different from the original color ramp, the values are the same. They just got cut down, but the division of the colors is different. So, now let's talk about how to classify this, just visually. So again, remember that the values in this raster are distances from some nuclear explosions. So out here in the blue, oops, I guess I don't want to select Africa, but out here in the blue we have a huge value. Here in the yellow, we have a smaller value. Okay, distance in meters to explosion. Why are we getting a little bit of yellow down here? Because I suspect there was some ocean explosion, and so these are, again, close to the ocean explosion. We could change this to a classified symbology. That's pretty horrible. But just suppose we wanted zones of like, you're close, you're in danger, you're medium, you're not much in danger, and you're far, you're in no danger at all or something. We could have 3 classes. And we can set the breakpoints on those classes anywhere we want. So if we go to more here, no, that's not it. Well, we can slow click on these and change the values. So suppose you only thought that you were in danger at 100 kilometers. So 100 and then 1,000 because it's meters. And suddenly we lower the amount of values that get that yellow color. This is visual reclassification. And we can, change the labels on it. So we could call this, low. Or rather, excuse me, this is the highest risk. So this would be high and medium and low. You all know how to do this. But in doing so, we haven't actually changed the values in the raster. If I turn off the continents so I don't get a big mess, and I just start clicking, I'm still getting those original distance values. There is, however, a tool that allows us to change those values into 3 or more classes of values permanently in the raster itself, not just symbolically. So that is a toolbox tool. It lives in the spatial analyst tools. It has a whole little tool set of its own. It's called reclass. And while there are a few choices here, we are going to reclassify it. The input raster will be the distance to explosion for Africa. The reclass field will be the value. You will find that the only 2 things you could possibly put in this field are value and maybe count sometimes. But you always want this to say value. And then we have a table that allows us to define ranges of values, a starting point, a stopping point, and then the new value we want to assign to it. We also have these two buttons. I'm going to say right now that unique is not a good one to use when you have distance values because every single pixel is probably unique. But we can classify it and tell it right now that we want, say, 3 classes. And it will make some guess, probably based on natural breaks or equal interval, of where we want those cutoffs to be. And then the new values that we want assigned to them. Now, in our other example, we put 100,000 here, and I'm going to have to put 100,000 here to match it. So everything that's currently yellow from 0 to 100,000 will get a value of 1, like a risk score of 1. The next category, everything that's orange will get a risk score of 2, and then a risk score of 3. We can also change these. You can't give them text values. So we could not put low, medium, and high here. But what we could do is we could say rate them on a scale of 100. Like 100 is a big risk. And then these only get a score of 50. And then these get a score of 0. And what goes on down here? Remember we mentioned no data? No data is all the stuff that is currently on the map right now that is white. So I even notice a couple of white pixels up here. That's probably a water body and it's not showing up. So everything that's left out of the map is no data. We can even mess with no data. For example, if we wanted all of these low risk places to be considered no data, as long as you use the same sort of spelling and capitalization scheme, that is something you could do. We could just eliminate those red sections from the map entirely. From the raster entirely. The raster itself will have nothing there. So this will be reclass Africa. And let's run it and just see what the output looks like. I have to turn off the old distance to Africa. So now here, if I use my identify tool, I have 100. Actually, this is a new raster. It only has 2 values, 50 and 100. It has 100 where you're seeing the pink and 50 where you're seeing this blue-green color. And out here, where there used to be that band of red, is all no data, same as the ocean. Okay. No data winds up being a powerful and useful tool that we will use a lot this coming week when we do cost distance. So it's really helpful to get a handle on it. One more thing I want to show you. We just reclassified a raster that it was a continuous raster. It had ranges of values. It had distance values. But we can even reclassify this discrete raster. So if I run reclassify on reclass Africa, I could change all of the 50s to 0s and all of the 100s to 1s and have a binary raster. Let's see what that looks like. I mean, it looks just the same, but over here in the table of contents, you see that the values are only 1 and 0, not 50 and 100. So as I said, reclassify winds up being very useful, and we will definitely make use of this when we do cost distance next week.